Before we do anything else, let everything in the room go a little bit softer. You can put the phone down now, face down, somewhere you don't have to reach for it. If there's a light still on, that's all right, but maybe let it be a small one, or cover it with something. Pull the blanket up a little higher if you want to. You don't need to sit up, you don't need to follow along. This is one of those things you can let wash over you, like rain on a roof while you're already warm inside. If you drift off halfway through a sentence, that's not missing anything. That's the whole point. And before we start, one small thing. This is a calm walk through a subject, made for rest and for gentle learning. It isn't professional advice of any kind, medical or otherwise, so please don't lean on it for anything that matters. And please don't listen to this while you're driving, or while you're doing anything that needs your attention. Find somewhere safe, somewhere you can stop moving for a while. If you'd like to come back to any of this while you're awake, the No Fluff Anatomy and Physiology Guide is at the link in the description, and it covers the same ground in a form you can actually read. But you don't need it tonight. Tonight you can just listen. The human body is a strange and busy neighborhood. There are houses everywhere, and roads, and little delivery trucks, and pipes and wires, and lights that flick on and off in patterns we barely notice. But unlike a real neighborhood, every single part of this one was built from the ground up, piece by piece, starting from something so small you couldn't see it without help. And the way it all fits together is not random. It's layered, like those wooden dolls that open up to reveal another doll inside, and another, and another. That's how your body works too. One level sits inside another, and another, until the whole thing is standing there in the mirror looking back at you. The smallest level we need to think about is the cell. A cell is the tiniest living unit. It's the smallest thing that can still be called alive. Your whole body is made of them. Not dozens, not hundreds, trillions. So many that if you tried to count one every single second, you'd still be counting long after the stars had moved. But you don't need to count them. You just need to know they're there, working quietly in the dark, like tiny soft machines that never truly switch off. Each cell is a little bag of salty water, really, wrapped in a skin so thin you can't see it, but strong enough to hold the shape of you. Inside that skin there's a little command center called the nucleus, and inside that command center is the instruction book for making you. The same instruction book, copied over and over into every cell. So every single part of you carries the same plan. A skin cell on your arm has the same instructions as a cell in your liver. The only difference is which pages of the book it reads. And when many cells that are similar to each other sit side by side, doing the same job, we call that a tissue. A tissue is like a neighborhood street where everyone has the same trade. On one street, all the houses are bakers. On another, all the houses are builders. In your body, one kind of tissue is for covering and lining. It's called epithelial tissue, and it's like the wallpaper and the roof tiles and the paving stones of the body. It covers your outside, lines your inside, and keeps the right things in the right rooms. Another kind is connective tissue, and that's the scaffolding, the glue, the packing material. It holds things in place and gives them shape. Bone is a type of connective tissue, and so is blood, strange as that sounds. Blood is a connective tissue that moves. It's like a liquid road that carries things from one part of the body to another. Then there's muscle tissue, which can shorten. That's its whole trick. It gets shorter, and when it gets shorter, it pulls on things, and that pull is what moves you. And finally, there's nervous tissue, which carries messages. It's the wire, it's the telephone line, it's the post. When something needs to happen, the nervous tissue tells the muscle tissue, and the muscle tissue pulls, and the body moves. Once you have different tissues working together toward one goal, you've made an organ. An organ is like a building in the neighborhood with a particular job. The stomach is an organ. It has epithelial tissue lining the inside, muscle tissue to churn, connective tissue to hold its shape, and nervous tissue to know when food is there. All four tissues working in one place, doing one job. The heart is an organ. The liver is an organ. The skin is the biggest organ of all. and it's all four tissues woven together into a single coat that covers you from the top of your head to the soles of your feet. Every organ is a small community of tissues living together and sharing the work. And when many organs work together towards something even bigger, we call that a system. The stomach and the liver and the intestines and a few others all join forces to turn food into fuel. Together they make the digestive system. The heart and the blood vessels and the blood itself make the circulatory system. The nose and the throat and the lungs make the respiratory system. Each system is like a city department. One handles transport, one handles waste, one handles messages, one handles energy. None of them works alone. The digestive system needs the circulatory system to carry nutrients away. The circulatory system needs the respiratory system to pick up oxygen. The respiratory system needs the muscular system to move the ribs so air can flow in and out. And the muscular system needs the nervous system to tell it when to move. And the nervous system needs the digestive system to make the fuel that keeps its wires humming. Round and round it goes. So that is the grand shape of things. Cells gather into tissues. Tissues gather into organs. Organs gather into systems. Systems gather into you. A whole body, standing there, breathing, warm, alive. And of all those systems, the one that gives the body its movement, its push and its pull, its quiet ability to hold still or to change shape, is the muscular system. That's where we'll wander for a while, but not too fast. We'll take it slowly, because the muscular system is not one thing. It's hundreds of different things, all with the same basic trick. They get shorter. They pull. And that pull, repeated in all sorts of directions and strengths, is behind almost everything you do. Even lying still in bed, there are muscles working in your chest, in your neck, in your back, just enough to keep you breathing, to keep your head resting where it is, to keep your body from folding onto the floor, like a warm towel. Most people, if you ask them what a muscle is, would point to a bicep. That's the bump on the front of the upper arm that appears when you bend your elbow hard. And that's a fine place to start, because it's a muscle you can find in the dark without moving much. If you let your arm rest at your side, completely still, you probably can't feel it. It's just there, soft and quiet. But if you slowly lift your hand toward your shoulder, even just a little, something changes in the upper arm. It gets firmer. It bunches. That's the muscle shortening. And when a muscle shortens, it doesn't push. It pulls. It pulls the forearm up toward the shoulder. So the arm bends. Then, when you let the arm lower again, the muscle lengthens. It doesn't push the arm down. Not exactly. Another muscle on the other side of the arm takes over for that. Muscles work in pairs, usually. One pulls one way, and its partner on the other side pulls the other way. It's like two people holding opposite ends of a rope through a pulley. One person pulls to raise the bucket. The other person eases the rope out. Neither of them pushes. They only pull, and together they move the bucket up and down. That's the elbow. That's the bicep and its quiet partner on the back of the arm, the tricep. One pulls to bend the arm. One pulls to straighten it. Neither pushes. That's the first thing to understand about muscles. They only pull. Everything you've ever done, from walking to blinking to drawing a picture or holding a cup, is the result of something pulling on something else. And that pulling is done by tiny little fibers inside the muscle cell. If you could zoom in, and then zoom in again, and then zoom in some more, you'd find that a muscle is made of bundles within bundles, like a thick rope made of smaller ropes made of threads. And those threads are made of even finer proteins, and the proteins are arranged so they can slide past each other. When a signal comes down from the nervous system, those tiny protein threads grab on and slide, and the whole thing gets just a little bit shorter. One muscle cell shortening by a tiny bit isn't much. But when millions of them shorten together, all at once, the whole muscle shortens, and the body moves. That's the whole story of movement, really. The whole of dance, of running, of speech, of the slow rise and fall of the chest while you breathe, comes down to tiny protein threads sliding past one another inside billions of cells. It's so small that you can't see it without a microscope, and so constant that you never have to think about it at all. Most of it happens without you. Right now, without asking, muscles in your chest are pulling your ribs up and out just enough to let air in. Then they relax, and the ribs settle, and the air goes out, in and out. Thousands of times a day. Nobody has to remember to do it. The body just does it, quietly, in the dark, like a machine that runs itself. So if the bicep is a muscle you can find and feel, and the breathing muscles are muscles you never think about, then the heart is a muscle that fits somewhere else entirely. The heart is made of muscle tissue, but it's a special kind. It doesn't need you to tell it to beat. It has its own little clock inside it, its own tiny spark that sets the rhythm. It beats and beats and beats, from before you were born until the end, without ever stopping to rest in the way your arms and legs do. It rests between beats, of course. Each beat is a squeeze and then a long, soft pause. Squeeze, pause. Squeeze, pause. But it never takes a holiday. It never lies down. It never asks for permission. It just keeps pulling inward, over and over, pushing blood out to every corner of the body. And the blood travels through tubes, and the tubes are lined with other muscles that can squeeze and relax to help the blood along. Even the walls of your blood vessels have muscle in them, tightening and loosening, opening and closing, like tiny hands that decide how much blood goes where. When you're cold, muscles in the little vessels under your skin tighten to keep blood deeper inside, where it's warm. When you're warm, they loosen, and blood flows closer to the surface so heat can leave. All of it happening without a single thought from you. And the digestive system has muscle too. Not the kind you flex in the mirror, but a smooth, slow, rhythmic kind that runs along the inside of the stomach and the intestines. It squeezes in waves, over and over, pushing food along the way you might push toothpaste from the bottom of the tube. That's why you can eat lying down or standing on your head, and the food still travels the same direction. The muscle doesn't care which way gravity is. It just squeezes in a sequence, and the food moves along. This kind of muscle is called smooth muscle, because under a microscope it looks smooth, no stripes. The bicep kind is called skeletal muscle, because it attaches to the skeleton and moves the bones, and the heart kind is called cardiac muscle, because cardia is a Greek word for heart. 3 kinds of muscle, all doing the same fundamental thing. They shorten, they pull, but in different places with different rhythms under different control. Some of it you command, some of it commands itself, some of it only listens to the quiet, automatic part of your nervous system, the part that runs while you sleep. So when we talk about the muscular system, we're not just talking about the muscles you can see in the mirror. We're talking about the heart, the stomach, the walls of blood vessels, the little muscles that pull your hair upright when you're cold, the muscles that focus your eyes, the muscles that close your throat when you swallow so food doesn't go down the wrong pipe. Hundreds of muscles, maybe more than 600 depending on how you count them, and every one of them is doing the same simple trick. Shorten, pull, release. Shorten, pull, release. Some of them work for you, some of them work for the body, but all of them are woven into the same quiet, layered system that we've been talking about, the same neighborhood of tissues and organs that makes up a person. And if you let yourself sink a little deeper into the bed now, you can feel the truth of it. Not in a strong way, not in a way that demands attention, but somewhere in the background, your chest is rising and falling, your heart is beating, your eyelids are heavy. All of that is muscle. All of it is the body doing its work without asking you to help. Even the act of lying still is an act of muscle. It takes a constant, tiny amount of pull to keep your head from lolling, to keep your jaw closed, to keep your spine in its long, soft curve. Resting is not the absence of muscle. It's the muscles doing their smallest, slowest work, just enough to hold you in the shape of a person, while the night does the rest. Now, to understand how a muscle pulls on a bone, it helps to think about how it's built. A skeletal muscle, the kind we've been finding in the arm, is a long, soft organ with a thick middle and tapered ends. Those tapered ends become tough cords called tendons. A tendon is like the rope that ties the muscle to the bone. The muscle belly, the thick middle part, does the shortening. The tendon carries that pull to the bone. So the muscle pulls on the tendon, and the tendon pulls on the bone, and the bone moves. It's a very simple chain. Pull, transfer, move. And because bones meet at joints, like the elbow or the knee, the whole thing becomes a sort of lever system. The bone is the lever. The joint is the hinge. The muscle is the engine. When the engine shortens, the lever moves, and the joint bends or straightens or twists. That's the whole machinery of your skeleton. It's not complicated in principle, it's just repeated in hundreds of directions and sizes, so that your body can do everything from taking a step to writing your name. And a muscle doesn't attach to just any old place. It attaches with a plan. One end of the muscle attaches to a bone that stays mostly still. The other end attaches to a bone that moves. The still end is called the origin, and the moving end is called the insertion. You don't need to remember those words now, you can let them go. But the idea is simple. A muscle is like a rope tied between two posts. If one post is fixed and the other is free to swing, pulling the rope will move the free post. In the body, the fixed post might be the shoulder blade or the pelvis, and the free post might be the upper arm or the thigh. When the muscle shortens, the free bone moves toward the fixed bone. The shoulder pulls the arm closer to the body. The hip pulls the thigh forward. The heel pulls the foot down. Step by step, pull by pull, the body walks across the room. But a muscle can't work alone, not really. For every pull in one direction, there has to be a way to pull in the other. That's why muscles are arranged in teams. We touched on this with the bicep and tricep. The bicep bends the elbow. The tricep straightens it. They sit on opposite sides of the bone, like two people on a seesaw. When the bicep shortens, the tricep stretches, and the arm bends. When the tricep shortens, the bicep stretches, and the arm straightens. These pairs are called antagonistic pairs. One is the mover, and the other is the brake. One pulls, the other lets out the rope. And the beautiful thing is that they never both work at full strength at the same time. If they did, the joint would freeze in place. That actually happens in some states of extreme stress or certain illnesses, but in ordinary rest, the body balances them so smoothly that you never notice the negotiation going on. Every movement is a small peace treaty between opposing muscles. One agrees to shorten, the other agrees to lengthen, and the body moves. There's a third kind of muscle helper too, called a synergist. A synergist is a muscle that doesn't do the main movement but helps stabilize things so the main muscle can work properly. It's like someone holding the ladder while you climb it. The bicep might be the main puller when you lift a cup, but other muscles in the shoulder and the forearm are quietly bracing, keeping the wrist from flopping, keeping the elbow in line. Nothing in the body works in true isolation. Every single movement is a small concert of muscles, some pulling hard, some pulling gently, some doing almost nothing but waiting. And that is part of why the body is so good at what it does. It can spread the work across many muscles, in just the right proportions, changing from moment to moment. And here is a lovely, quiet thing about muscle. It remembers. Not in the way the brain remembers facts, but in the way a path through a forest remembers being walked. The more you move, the easier that movement becomes. The nerves that tell the muscle to fire get better at sending the message. The muscle cells get more efficient at using fuel. The connective tissue gets more comfortable with the pattern. So a movement that once felt awkward and difficult becomes smooth and automatic. That's what practice is, at the level of the body. It's the slow, patient wiring of nerves to muscles, repeating a pattern until it feels like it was always there. Even in sleep, some of this quiet learning continues. The brain replays patterns. The muscles stay still, but the blueprint is being redrawn. So you can let yourself rest and trust that the body is still working on itself, the way it always does, without being asked. But we've been talking about muscles as if they're all the same shape, and that's not quite true. Skeletal muscles come in many shapes and sizes, and their shape tells you something about their job. Some are long and strap-like the sartorius muscle in the thigh, which is one of the longest muscles in the body and helps you sit cross-legged. Some are fan-shaped, like the pectoralis major across the chest, spreading out to pull the arm in different directions depending on which fibers shorten. Some are flat and broad, like the muscles of the abdominal wall, which are less about moving bones and more about holding the soft contents of the belly in place, like a strong, living belt. Some are circular, like the muscle around your mouth and the muscle around your eye. A circular muscle shortens by closing. The eye muscle closes the eyelid. The mouth muscle closes the lips. Same trick, different shape. The body has found a way to use the simple idea of shortening and pulling in all these different geometries, to close, to lift, to twist, to hold. And all the while, the fundamental unit, the tiny protein threads sliding past each other inside the cell, stays the same. The difference is just how the cells are bundled, how the muscle attaches, and where the lever is. Let's stay with shapes for a little, because it's soothing to think about how the body is laid out like a map, with each muscle named after something simple. Many muscles are named for their location. The pectoralis is in the chest. The gluteus is in the buttock. The femoral muscles are near the femur, the thigh bone. Some are named for their size. Maximus means largest. Minimus means smallest. Longus means long. Brevis means short. So the gluteus maximus is the largest muscle of the buttock, and the gluteus minimus is a smaller one tucked beneath it. Some are named for their shape. The deltoid is triangular, like the Greek letter delta. The trapezius is a broad kite shape across the upper back. Some are named for how many heads they have. The bicep has 2 heads, the tricep has 3, the quadricep has 4. That's all. The names are just little descriptions, and once you hear them that way, they stop sounding like a foreign language. They're just the body's way of saying where something is, how big it is, what shape it takes, and what it does. But you don't need to remember any of these names tonight. That's not what this is for. The names are just labels. The real thing is the soft, constant pull of the body keeping itself together. The names can drift away. What stays is the sense of it, the feeling of being held, quite literally, from within. Every part of you is connected to every other part. The skin is attached to the tissue beneath it. The tissue is attached to the muscle. The muscle is attached to the tendon. The tendon is attached to the bone. And the bone is shaped and reshaped by the pull of the muscles on it. Even the bones are not fixed things. They respond to the force the muscles put through them. A bone that's pulled on regularly grows denser, stronger, better at being a bone. So the muscle and the bone are in a kind of quiet conversation. The muscle pulls, the bone responds. The bone holds, the muscle gets a steady anchor. They shape each other. The whole body is like that. Nothing is separate, nothing is wasted. Everything is in relation. And that brings us back to the layered view we started with. The cell, the tissue, the organ, the system. The muscle cell is part of the muscle tissue. The muscle tissue forms the muscle organ. The muscle organs, together with the bones and the tendons and the nerves, form the muscular system. And the muscular system is part of the whole body, which is part of a person, which is lying here in the dark, listening to a voice, letting the words pass over them like weather. You don't have to hold on to any of it. The body already knows all of this. It's been doing it since before you could speak, since before you opened your eyes for the first time. The same little proteins were sliding inside the cells of your heart when you were only a few weeks old, no bigger than a grain of rice. The same smooth muscle was moving in the walls of your stomach before you ever tasted food. The body has been practicing this for a very long time. It doesn't need you to learn the words. It just needs you to rest and let it keep doing what it does. So we'll leave it there for now, not at an ending, but at a resting place. There's a lot more to the muscular system, of course. There's the whole question of how the nerve tells the muscle to fire, and what fuel the muscle burns, and why muscles get tired, and what happens when they grow, and why they ache. But none of that needs to be talked about right now. For now, the important thing is just the simple shape of it. Muscles pull. They pull on tendons. The tendons pull on bones. The bones move. And all of it happens inside a body that is arranged in layers, from tiny cells to whole systems. And you don't have to do a single thing to make any of it happen. It's happening right now. The chest rising, the heart beating, the eyelids heavy, the muscles of the neck just barely holding the head in place, the muscles of the jaw just barely relaxed enough to let the mouth fall open, just a little, the way it does when sleep is close. That's the muscular system at rest. Not off, just settled. Not absent, just quiet. Pulling gently, the way the tide pulls on the shore, too soft to notice, too constant to stop. And if you're still awake enough to notice, that's all right too. You don't have to chase sleep. You can just let the words keep coming, slow and steady, like water moving through a wide, flat river. There's no rush. The body is not in a hurry, and neither are we. So we were talking about the simple shape of the muscular system. Muscles pull. They pull on tendons. Tendons pull on bones. Bones move. And the whole thing is arranged in layers, from tiny cells to whole systems. That's the map. Now we can wander a little further into one part of that map, because the next thing to understand is how the muscle knows when to pull. Something has to tell it. Something has to carry the message from the dark, quiet center of you all, the way out to the edge of a moving arm or a breathing chest. And that something is the nervous system. You can think of the nervous system as the body's postal service. It has a central sorting office, which is the brain and the spinal cord, and it has delivery routes, which are the nerves. The nerves reach out from the spine into every part of the body, like roads spreading out from a city into the countryside. Some of these roads carry messages toward the center. Those are the sensory nerves. They bring news of heat and cold, of pressure and pain, of where the limbs are in space. Other roads carry messages away from the center. Those are the motor nerves. The motor nerves are the ones that matter for muscles, because the word motor means movement. Motor nerve is a wire that carries the instruction to move. It runs from the spinal cord all the way out to a muscle, sometimes quite a long way. A single motor nerve cell can be 3 feet long in a tall person, reaching from the lower back all the way down to a muscle in the foot. It's one of the longest cells in the entire body, a tiny, delicate thread carrying the spark that tells the foot to point or the toe to curl. When a motor nerve reaches a muscle, it doesn't just touch it, it makes a special connection, a little junction, like a plug fitting into a socket. This junction has its own name, the neuromuscular junction, but you can let that go if you want. The important thing is that the nerve and the muscle don't actually touch. There's a tiny gap between them, much too small to see, and across that gap, the nerve sends a chemical message. The chemical is called a neurotransmitter, and the one at the muscle junction is called acetylcholine. That's a long word, but it's just a tiny key that fits into a tiny lock on the muscle side of the gap. When the nerve signal arrives, it releases a little puff of this chemical. The chemical drifts across the gap, fits into the lock, and unlocks a change in the muscle. That change is what causes the tiny protein threads inside the muscle cell to slide past each other. So the whole thing, from thought to movement, is not one single bolt of lightning. It's a chain of small events. A signal travels down the nerve, a chemical is released. The chemical crosses a gap, it unlocks the muscle. The muscle shortens, and the body moves. And that happens so quickly that you never notice the steps. By the time you decide to wiggle your finger, the finger is already wiggling. In fact, the decision and the movement happen so close together that it's hard to say which one comes first. Sometimes the body moves before the conscious mind has fully formed the idea of moving. You snatch your hand away from a hot surface before you've even felt the heat. That's because the spinal cord has its own quick circuit, a reflex, that can act without waiting for the brain. The message comes in from the sensory nerves, and the spinal cord sends a message straight back out to the muscles, all before the brain has had time to read the letter. That's why you pull your hand away before you know why. The body is always looking after itself, quickly and quietly, without bothering the conscious mind with every little decision. But most of the time, the movements we choose are softer and slower, and the brain is involved. The brain has a whole map of the body laid out on its surface, like a little person drawn across the top of the brain. The hands get a huge amount of space on that map because the hands are capable of very fine movements. The lips and tongue get a lot of space too because speech is so detailed. The back gets a small space because the back doesn't need to make many fine distinctions. It just needs to hold. This map is called the motor cortex, but the name doesn't matter much right now. What matters is that the brain contains a picture of you, and that picture is constantly sending messages out along the motor nerves, telling the muscles what to do. Even now, as you lie here listening, the motor cortex is busy in a soft, slow way. It's keeping the breath steady. It's adjusting the tiny muscles of the ear. It's allowing the eyes to rest without focusing. It's keeping the small movements going, the little shifts and settles that happen without you deciding them. The motor cortex is never completely silent. It hums along, like a radio tune between stations, but only the quietest part of it reaches you. And here's a thought worth resting on. When you fall asleep, the motor system doesn't switch off. It simply changes its tone. The body enters a different kind of management. Many of the voluntary muscles relax deeply. The jaw drops open a little, the limbs get heavy, the neck softens, but other muscles keep working exactly as before. The diaphragm keeps pulling air into the lungs. The heart keeps squeezing. The smooth muscle in the gut keeps moving in slow waves. Sleep is not the absence of the body's work. It's a change in which parts of the work come to the front. The voluntary muscles step back. The automatic muscles stay on. And the brain, which is not a muscle but works like a very busy organ, begins its own night shift. It sorts through the day. It replays patterns. It bathes the whole system in slow waves of rest. And through it all, the muscular system holds you in the shape of a sleeping person. Not rigid, not stiff, just held, like a hammock holding someone in the dark. There is no effort in it, and yet there is no collapse either. It's a balance. The muscles have just enough tension to keep the body safe and comfortable, and no more. That state has a name too. It's called muscle tone. Not tone in the sense of being fit or looking a certain way. Tone in the sense of a quiet, resting readiness. A little bit of pull, even when nothing needs to move. The body never goes completely slack. It always keeps a small amount of tension in the muscles, like a sail that is not being driven by the wind, but is not completely furled either. That gentle, constant readiness is what keeps your head from rolling off the pillow when you're deeply asleep. It's what keeps your spine from folding strangely. It's what keeps your jaw from hanging completely open in a way that would dry out your throat. It's the body's way of saying, I'm here, I'm holding, I haven't gone anywhere. And if we stay with this idea of tone, we can understand something else about the body. The muscles are not just machines for moving. They're also part of the body's shape. When a person stands, their shape is not just bones stacked on top of each other, it's bones held in a living, adjustable framework of muscles. The curves of the spine are supported by the muscles along the back. The arch of the foot is held by muscles and tendons. The belly is supported by the abdominal wall, which is several layers of muscle crossing each other at different angles, like sheets of fabric laid over one another. When those muscles have good tone, they hold the soft organs in place and give the trunk a kind of gentle, resilient shape. When they're very relaxed, like right now as you lie down, the belly can soften and spread, and that's exactly what it should do. There's no need for the body to be held tightly when you're already lying down. The muscles can let go, the tone can lower, the whole body can settle into the surface beneath it. But even in that settled state, the muscles are not completely off. If they were, you wouldn't be able to roll over, or adjust your head, or clear your throat. The tone is low, but it's still there, like the pilot light on a stove, ready but not blazing. That's the normal state of a muscle at rest. Ready but not working, present but not active. And that's worth thinking about as you lie there, because it means that resting is not failure, and stillness is not absence. The body is designed to rest. It's designed to spend a third of its life asleep, with the voluntary muscles soft and the automatic muscles steady. The muscular system is not a system that demands constant use. It's a system that thrives on a rhythm of work and rest, of pull and release, of tension and ease. The very structure of a muscle, the tiny protein threads, works by pulling and then letting go. Pull, release. Pull, release. That rhythm is built into the smallest part of the system. So when you rest, you're not dropping out of the rhythm, you're joining it. You're letting the release part of the cycle have its turn. Now, to understand how a muscle actually changes when it pulls, we have to go down to the smallest level for a while. Not because you need to remember it, but because it's soothing to know that the body is made of such small, orderly things. If you took a single muscle cell, which is also called a muscle fiber, and looked at it under a very powerful microscope, you'd see that it's long and thin, like a thread. And inside that thread are even smaller threads, running the whole length of the cell. These are called myofibrils, and they're the actual pulling machines. If the muscle cell is a rope, the myofibrils are the individual strands that make up the rope. And if you looked even closer at a myofibril, you'd see that it's divided into repeating units, like a chain made of identical links. Each link is called a sarcomere. That's the smallest complete pulling unit in the body. It's so small that thousands of them fit along the length of a single muscle fiber. But each one can shorten a tiny amount, and when millions of them shorten together, the whole muscle moves. Inside each sarcomere are two kinds of protein thread. One kind is thick, it's called myosin. The other kind is thin, it's called actin. The thick myosin threads sit in the middle of the sarcomere, and the thin actin threads attach to the ends and point inward, like two combs facing each other with their teeth almost touching. When the signal arrives, the myosin heads, which are like tiny little arms, reach out and grab the actin threads. Then they pull the actin toward the center. Then they let go, reach again, and pull again. It's like a group of tiny rowers, pulling on oars, over and over, in rhythm. Each pull moves the actin a minuscule distance closer to the middle, but there are so many myosin heads, and they pull so many times, that the whole sarcomere shortens. And when every sarcomere along the fiber shortens, the fiber shortens. And when enough fibers shorten, the muscle shortens. And when the muscle shortens, it pulls on the tendon, and the bone moves. That's the whole chain. From a chemical signal at the junction, to a tiny arm reaching out, to a pull, to a shortening, to a movement. It's the smallest thing you can imagine, repeated so many times that it becomes visible, becomes useful, becomes the reason you can turn over in bed, or lift a glass of water, or take a breath. And all of that work requires energy. Nothing in the body happens for free. The myosin heads need fuel to pull. That fuel is a molecule called ATP, which is the body's little energy coin. Every single pull of every single myosin head spends ATP, and because there are so many pulls happening all the time, the body has to make ATP constantly. It makes it from the food you eat, mostly from sugars and fats, and it stores a small amount right in the muscle for quick use. When the muscle works hard, it uses up the stored ATP quickly, and then it has to make more from other fuel. That's one reason muscles get tired after a long effort. But right now, while you're lying still, the muscles are working at such a low level that they have plenty of ATP. They're not in any hurry, they're just idling, like a car engine at a stoplight, barely using fuel, just enough to keep things warm and ready. And here's a lovely thing about the body at rest. When you're lying still, the muscles are not the main users of energy, the brain is. The brain uses a large share of the body's energy, even when you're asleep. It's a busy organ, always sorting and balancing and regulating. The heart uses a steady share too. The liver and the kidneys, the gut and the skin, all of them hum along. The body is never really off, but the voluntary muscles, the big ones in the arms and legs and back, they can go very, very quiet. Their energy use drops to almost nothing. That's why sleep is so restful. Not because the body stops, but because the big muscles finally get to idle. The constant small demands of the day, the standing and sitting and holding and adjusting, all of that eases off. The muscles soften. The energy they were using is freed up for other things. The brain uses it to sort memories. The immune system uses it to repair. The whole body shifts from doing to being, from work to maintenance. So the tired feeling you might have right now, the heaviness in your limbs, the way the pillow seems to be pulling your head down into it, that's not a sign that something is wrong. It's the muscular system beginning to let go. It's the tone lowering. It's the voluntary muscles stepping back from the day. It's the body giving itself permission to be still. And you don't have to fight it. You don't have to stay awake to prove anything. The body has been doing this for millions of years. Long before there were words for it, long before there were beds and blankets and lectures. It knows how to rest. It knows how to soften. It knows how to pull and release, until the release is bigger than the pull, and sleep comes up like water filling a footprint. Let's stay with the idea of pull and release for a moment, because it's the deepest rhythm of the whole muscular system. Every muscle works in cycles. It shortens and then it lengthens. It works and then it rests. The heart does this. It squeezes and then it relaxes. The diaphragm does this. It pulls down to bring air in and then it relaxes to let air out. The gut does this. It squeezes in waves. Then the wave passes and the gut is still for a moment before the next wave comes. The whole body is made of rhythms like this. Not one constant, unchanging effort, but a pattern of effort and ease, of work and rest, of pull and release. And the longer you lie still, the more you can feel this rhythm if you pay attention, or even if you don't. It's there in the slow rise and fall of the chest. It's there in the soft, steady beat of the heart. It's there in the tiny adjustments your muscles make as you sink deeper into the mattress. The body is not a machine that runs at one speed. It's more like weather or water or the slow turning of leaves in the evening air. It moves in waves. It rests in waves. And sleep, when it comes, is just the biggest, softest wave of all. And so we can leave the microscopic machinery for now. We can come back up to the level of the whole body, where the muscles are arranged in great sheets and straps and rings, all working together. The back muscles hold the spine. The abdominal muscles hold the belly. The leg muscles hold the body up. The arm muscles reach and grasp. The neck muscles balance the head. And all of these big, visible muscles are connected to the quieter muscles inside, the heart and the gut and the vessel walls, through the same basic pattern of pull and release. The body is one piece of music, played on many instruments, all following the same slow score. You don't need to know the names of all the instruments. You just need to know that they're all playing for you, even now, especially now, while you lie there and let the night do its work. The next thing we could talk about, whenever you're ready, is what happens when a muscle is asked to do more than rest. What happens when you walk or climb or carry something heavy, how the muscle gets stronger, how it gets tired, why it sometimes aches the day after. But all of that is for later. For now, there's no need to go anywhere. The body is here. The breath is here. The soft, steady pull of the heart is here. And that's enough. That's more than enough. The rest can wait. It will still be there, waiting quietly, like everything else, until it's time to pick it up again. The room is probably very quiet now, or as quiet as it's going to get. Maybe there's a hum from outside, or the soft sound of your own breathing, or the faint rustle of the blanket when you shift. Those sounds are all right. They're not interruptions. They're just part of the texture of the night. Let them be there. You don't need to listen to them, and you don't need to push them away. They can just exist, the way your heartbeat exists, the way the air exists. The body is very good at being in the world without having to manage it. It just rests there, and lets the world rest too. Now we've talked about the quiet state of muscle, the soft tone that holds you together while you sleep, and we've talked about the tiny machinery, the myosin and actin, the pull and release. Now let's think about what happens when the muscle is asked to do a little more. Not a lot more, just a little, enough to lift a glass of water, enough to roll over, enough to take a slow walk through the house to the bathroom and back. What changes in the muscle between rest and gentle movement, and then between gentle movement and real effort? Because the body is not just one steady flame. It can turn itself up and down like a stove with many burners, and it does this so quietly that you never notice the adjustment. The first thing that happens when a muscle is asked to do more is that the nervous system sends more signals. Not a different kind of signal. Just more of them, more quickly. Each signal triggers a tiny release of the chemical at the junction, and each release causes a brief pull. When the signals come slowly, the muscle just twitches lightly, not enough to move anything. As the signals come faster, the twitches merge into a smooth, steady pull. That's how a muscle moves a bone. It's not one big blast of effort. It's many small pulls, blended together, the way raindrops on a window blend into a sheet of water. The rate of the signals is called frequency, and when the frequency goes up, the muscle pulls harder. It's as simple as that. More messages per second means more myosin arms reaching out and grabbing. More grabs means more pull means more movement. But the nervous system has another way to change the strength of a muscle's pull. It can recruit more muscle fibers. A muscle is not one single unit. It's made of hundreds or thousands of individual muscle cells, each one a separate thread, and the motor nerves that serve the muscle are divided into small groups, each one responsible for a little patch of fibers. These groups are called motor units. A motor unit is one nerve cell and all the muscle fibers it talks to. When the body wants a very fine movement, it uses small motor units, where one nerve controls just a few fibers. That gives a lot of control. The muscles of the eye have tiny motor units, some with only a handful of fibers each, because the eye needs to make very precise, tiny adjustments. When the body wants a powerful movement, it uses large motor units, where one nerve controls hundreds of fibers at once. The big muscles of the thigh and the buttock have enormous motor units because they don't need fine control. They need strength. They need to be able to stand you up from a chair or push you up a flight of stairs. So when a muscle needs to pull harder, it does two things at once. It increases the frequency of the signals, and it recruits more motor units. It calls in more workers, and it asks each worker to pull more often. The smallest motor units are recruited first, because they're the most easily triggered. Then, as the effort increases, the bigger ones join in, then the biggest ones. It's like a choir gradually adding voices, soft at first, then fuller, then full. And when the muscle is working very hard, all the motor units are firing, and the muscle is pulling with everything it has. But most of the time, the body keeps a lot in reserve. You never use every motor unit in a muscle at once, unless you're in an emergency, or lifting something extraordinarily heavy. The body is very good at spreading the load, so that some fibers are always resting while others are working. That's why you can stand up for hours without your legs giving out. The muscle fibers take turns. Some pull, then rest. Others pull, then rest. The body is always sharing the work, like a long line of people passing buckets, each one taking a turn and then stepping back. And as the muscle works, it needs fuel. That brings us back to ATP, the little energy coin. The muscle keeps a small store of ATP ready for immediate use, but it doesn't last long, only a few seconds of full effort. So the muscle has backup systems. It has a molecule called creatine phosphate, which can quickly recharge the ATP, like a little battery booster. That gives a bit more time, maybe 10 or 15 seconds. Then the muscle has to start breaking down sugar. It can do that without oxygen for a short while, a process that makes a little bit of ATP, but also makes a byproduct that can make the muscle feel tired and heavy. That's the burn you feel when you lift something over and over. It's not damage. It's just the muscle working without enough oxygen, the way a candle burns differently when the air is thin. But for gentle movement, the muscle uses a much cleaner and more sustainable process. It uses oxygen to break down sugar and fat, and it makes a great deal of ATP without any noticeable burn. That's the system you're using right now, as you lie there breathing slowly. The muscles are using a little bit of fuel, a little bit of oxygen, and they're making just enough energy to keep the body settled and warm. The byproducts are carbon dioxide and water, which the blood carries away quietly. The breath takes the carbon dioxide out. The kidneys and the skin deal with the water. The whole thing is a closed, gentle loop with no rush and no waste. And that's the thing to hold on to. The body at rest is not lazy. It's not failing to produce. It's simply running on the cleanest, slowest, most sustainable system it has. The muscles are burning a little bit of fuel in the presence of plenty of oxygen, and the result is stillness, warmth, and a slow, steady supply of energy. That's the state you're in now. It's not a lower state. It's the body's preferred state. The quiet hum of a well-tuned engine at idle, the soft, glowing ember, the slow tide. It doesn't need to be more than that. It just needs to be allowed to continue. When a muscle has been working for a long time, or very hard, it gets tired. But tiredness is not a single thing. It's not the same as the tiredness you feel in your whole self at the end of a day. Muscle fatigue is something more local. It happens when the muscle can't get enough fuel, or when the signals from the nerves slow down, or when the byproducts of work build up faster than the blood can carry them away. It's a signal, really. Not a failure, a message. The body is saying, enough for now. Let this part rest. Let the blood come and clear the byproducts. Let the energy stores refill. And if you listen to that message, if you stop and rest, the fatigue passes. The blood does its work. The liver and the muscles refill their little stores of sugar. The oxygen levels come back up, and the muscle is ready again. The body is built to recover. It's built to be tired and then to be renewed. The rhythm of work and rest is written into every fiber. And that leads us to something else. Something that happens when a muscle is asked to work a little harder than usual, not just once but regularly. The muscle adapts. It gets bigger, or more efficient, or both. That's what people mean when they talk about getting stronger or getting fit. The muscle doesn't grow new fibers. Not in the way you might think. It grows the fibers it already has. The individual muscle cells get thicker. They make more of the contractile proteins, the myosin and actin. They make more mitochondria, which are the tiny power stations inside the cell where oxygen is used to make ATP. They make more of the enzymes that help break down fuel. The whole cell becomes better at doing what it does. And the nervous system also gets better. It learns to recruit the motor units more smoothly, in the right order, with the right timing. So the strength of a muscle is not just about how big it is, it's also about how well the nervous system can drive it. A person can get much stronger without their muscles getting visibly bigger, simply because the nerves learn to call on more of the fibers that are already there. The body is always learning, always adjusting, always trying to make the work easier. That's one of its quiet gifts. It doesn't complain, it just adapts. And the opposite can happen too. If a muscle is not used for a long time, it shrinks. The fibers get thinner. The mitochondria become fewer. The nervous system gets rusty. But even this is not a failure. It's the body being efficient. It doesn't keep paying for machinery it doesn't need. If the leg is in a cast, the calf muscle shrinks because the body says, "Why should I keep this big expensive engine if it's not being used?" And then, when the cast comes off and the leg starts to move again, the muscle slowly rebuilds. The body is very good at matching its equipment to its needs. It's not wasteful and it's not sentimental, it just adjusts. Up when there's work, down when there's rest. Up and down like the tide, like the seasons, like the slow turning of the body's many quiet dials. But none of that needs to concern you tonight. You're not in training, you're not recovering from an injury, you're just lying there, and the body is doing what it does best, which is maintaining itself in a state of gentle, sustainable balance. The muscles are at their lowest useful setting, the heart is beating, the breath is moving, the blood is making its slow rounds, bringing oxygen, taking away carbon dioxide, delivering a little fuel, clearing a little waste. The whole system is in a state of quiet reciprocity. Everything gives, and everything receives. The blood gives oxygen to the muscles, and the muscles give back carbon dioxide. The nerves give signals to the muscles, and the muscles give back movement, or stillness. The bones give anchor to the muscles, and the muscles give stress to the bones, which keeps the bones strong. Every part of the body is in a constant, quiet conversation with every other part, and the conversation is not made of words. It's made of chemicals and electrical signals, and the slow pull of one tissue on another. It's a language too old for speech, and it never stops, not even when you do. So let's return to the whole body for a while, and look at how the muscles are arranged. Because the map of the muscles is not random. It's a reflection of how the body moves, and how it needs to be held together. The muscles of the back, for example, are arranged in layers. Deep, small muscles connect one vertebra to the next, holding the spine in its gentle curves and allowing it to bend and twist in small, precise ways. Above those are longer muscles that span many vertebrae, helping the back to extend and straighten. And above those are the big, broad muscles that move the shoulders and the arms. When you lie still, all these layers are at rest, but they're still holding the spine in its natural shape. If you've ever seen a building with many internal struts and supports, that's what the back is like. The bones are the beams, and the muscles are the tension cables that keep the beams in line. Without the muscles, the spine would not stand. It would fold. The muscles are what make the skeleton into a body. The abdominal wall is similar. It's made of layers. The outermost layer is a broad sheet that runs diagonally, like the weave of a basket. Beneath it is another sheet running in a different direction. Beneath that, a thin layer that runs across. And beneath that, a vertical strap that runs from the ribs to the pelvis. Together, these layers wrap the belly like a strong, flexible bandage. They do more than hold the organs in. They also help with breathing, especially when you breathe out. They help with posture. They help with lifting, twisting, and bending. And when you're lying down, they soften. The belly rises and falls with each breath. There's no need for the abdominal wall to be tight. It can just be a soft, warm covering, moving gently with the breath, like a calm sea under a light breeze. The muscles of the legs are the biggest in the body, and that makes sense, because the legs have to carry the whole weight of you. The gluteal muscles of the hip are large and powerful, and they do the work of straightening the hip when you stand up or climb. The quadriceps on the front of the thigh straighten the knee. The hamstrings on the back of the thigh bend the knee and help extend the hip. The calf muscles on the back of the lower leg point the foot down, which is what pushes you forward when you walk. All of these muscles are connected to the bones by strong tendons, and they work together in long chains. When you walk, it's not just the legs that move. The hips swing. The trunk rotates a little. The arms swing in counterbalance. The neck holds the head level. The eyes make tiny adjustments. The whole body is involved in every step. Walking is not a leg activity. It's a whole body activity, and the legs are just the part that touches the ground. But lying here now, the legs don't need to walk. They can just rest, heavy and soft against the bed. The gluteals can let go, the quadriceps can lengthen, the hamstrings can settle, the calves can be still. The long chains of movement that carried you through the day can finally go quiet. And when they go quiet, the blood doesn't have to work as hard to pump through them, because the muscles aren't demanding fuel. The heart can slow. The whole body can drift down into that low, warm state where the pulse is slow and the breath is shallow and the skin is just a little bit cooler. That's the body's night mode. Not a different body, the same body, running the same systems, just on the gentlest possible setting. Now, There's one more thing worth touching on before the next rest, and that's the way the muscles and the bones work together across a joint. Because a joint is where movement happens, and the muscles are the engines of that movement. At a simple hinge joint like the elbow, the bones fit together so they can swing one way and not the other. The muscles are arranged on either side. One bends, one straightens. We've talked about that. But the body has many different kinds of joints. The shoulder is a ball and socket joint, which means it can move in almost any direction. That's why the shoulder needs a whole team of muscles around it, not just two. Some lift the arm, some lower it, some pull it forward, some pull it back. Some rotate it inward, some rotate it outward, and at any given moment, all of these muscles are working at different intensities, some pulling, some holding, some just keeping the joint steady. The shoulder is like a tent, held up by many ropes. The bones are the poles, the muscles are the ropes. And the tension in the ropes keeps the whole thing upright and stable. The same is true of the hip, which is another ball and socket joint, and the spine, which is a long chain of small joints, each one with its own little team of muscles. And the knee, which is often thought of as a simple hinge, is actually more complicated. It bends and straightens, yes, but it also has a little bit of rotation, and it depends heavily on ligaments and tendons for its stability. The muscles around the knee, the quadriceps and the hamstrings and the calf, do more than move the joint. They also protect it. They control the speed of bending. They hold the kneecap in its groove. They absorb shock when the foot strikes the ground. When you lie down and let the legs go still, the knee is completely unloaded. The bones aren't pressing together. The muscles aren't pulling. The joint just rests in a soft, slightly bent position, the way it likes to be. If you've ever fallen asleep with your knees slightly bent, that's the body finding its most comfortable resting shape, not fully straight, not fully bent, but somewhere in between, where the joint capsule is at ease and the muscles are at their lowest tension. There's a word for that middle position. It's called the resting length of a muscle. Every muscle has a length at which it can produce the most force if asked, but also a length at which it is most comfortable. That length is usually somewhere in the middle of its full range. Not fully stretched, not fully bunched, just easy. When you sleep, the body tends to find these resting lengths. The neck is neither fully bent nor fully straight. The elbows are neither fully open nor fully closed. The hips and knees are slightly flexed. The ankles are relaxed. The body curls a little or lies long, depending on how you're lying, but in every position, the muscles settle into their easiest lengths, the lengths where the pull is smallest and the comfort is greatest. That's part of why sleep is so restoring. The muscles are not just resting, they're resting at their best. And so the body lies there, arranged in its layers, held by its muscles, breathing its slow breath, and the night goes on. There is nothing to fix, nothing to accomplish, nothing to remember. The muscle fibers are not in a hurry. The motor units are quiet. The ATP is being made at a slow, steady pace. The blood is moving softly. The heart is squeezing and releasing, like a slow clock in a warm room. And somewhere in the brain, the map of the body is dimming, the motor cortex going quiet, the signals to the voluntary muscles becoming less frequent, less urgent. The body is letting go, bit by bit, and the mind is letting go too. And that's the right order of things. The body goes first, softening into the bed, and the mind follows after, like a small boat slipping its mooring and drifting out on a still, dark lake. There's no need to hurry it. There's no need to hold on. The muscles know how to let go, and so do you. If you've made it this far, you're probably somewhere between awake and asleep, and that's exactly the right place to be. Not fully here, not fully gone, just drifting on the edge of things, where the words come in like sounds from another room. You don't have to hold on to them. They'll be here, doing their slow work, whether you follow them or not. The body is still breathing, the heart is still beating, the muscles are still soft, and the night is still moving, slowly, the way it always does when no one is watching. Let's pick up the thread again, gently, because there's no need to be abrupt. We've been talking about muscles at rest and about how they move the body when they're called on. Now we can think about one of the more practical things, which is what muscles are made of, not just in the sense of proteins and fibers, but in the sense of flesh and blood and the living stuff of you. Because a muscle is not a dry machine, it's a wet, warm, living tissue full of water and blood and energy. Most of a muscle's weight is water. The rest is protein, mostly, with some fat and minerals and stored fuel. The water is what makes the muscle soft and pliable. The protein is what makes it able to pull. The blood vessels run through it like tiny rivers, bringing oxygen and fuel and carrying away waste. The nerves run through it like fine wires, bringing signals. The whole thing is alive in a way that a machine never could be. It's warm, it's moist, it responds, it adapts, it heals, it grows, it rests. It's not just a pulley system, it's a part of you. And because it's alive, it has a blood supply. Muscles are very vascular, which means they have a lot of blood vessels. That's because they need a lot of oxygen and fuel when they're working, and they need a way to get rid of the byproducts. When a muscle works, the blood flow to it increases. The vessels open up, the heart pumps a little harder. The blood carries more oxygen into the muscle and more carbon dioxide away. That's why working muscles feel warm. The warmth is the blood moving through them, carrying the heat that comes from the chemical reactions of energy production. And when a muscle rests, the blood flow slows down, the vessels settle, the muscle cools a little. But even at rest, the blood is still there, still moving, still keeping the tissue alive. If you've ever felt a muscle twitch or jump when you were lying still, that's just a little motor unit firing on its own, a tiny ripple of activity in a muscle that's otherwise at rest. It's harmless, it's just the body humming. The nervous system is also part of every muscle. We've mentioned the motor nerves, the ones that carry signals from the spine to the muscle. But there are also sensory nerves in the muscle. They carry information back to the spine and the brain. They report on how stretched the muscle is, how much tension it's under, how quickly it's moving. These sensory nerves are called proprioceptors, and they're the reason you know where your limbs are, even with your eyes closed. Right now, without looking, you know whether your knees are bent or straight, whether your hands are open or closed, whether your head is turned to one side. That knowledge comes from the proprioceptors in the muscles and tendons, quietly reporting to the brain. They never sleep. They just keep whispering their little updates, even in the dark, even when you're on the edge of sleep. That's how the body keeps track of itself. It's not through sight, it's through the deep, quiet sense of position, the sense of being a body in space. And that sense is part of what makes lying still feel so odd sometimes. When you first settle into bed, your proprioceptors are still awake, still reporting. They tell the brain, the left foot is turned out, the right hand is under the pillow, the neck is slightly bent, and the brain, in its half-awake state, notices these reports and lets them go. It doesn't need to act on them, it just receives them and drifts on. That's part of falling asleep. Not the end of sensation, but the softening of attention. The reports keep coming, but the brain stops listening so closely. The body stays where it is, held by the muscles, known by the nerves, and the mind steps back from the whole arrangement. It's a very gentle thing, when it works. A loosening of the grip, a dimming of the lights, a slow, sweet giving up of the need to manage everything. Now, let's think for a while about the different kinds of muscle tissue in the body, because we've touched on them but haven't really walked through them slowly. There are 3 kinds: skeletal muscle, smooth muscle, and cardiac muscle. They all pull, but they look different under a microscope, and they work in different ways, and they answer to different masters. Skeletal muscle is the kind we've mostly been talking about. It's the kind you can control. It's attached to the skeleton, and it moves the bones. It's striated, which means it has stripes when you look at it under a microscope. The stripes come from the way the protein threads are arranged in repeating units, the sarcomeres. They're so regular that they create a pattern, like the stripes on a fabric. Skeletal muscle is quick. It can contract and relax very fast, faster than the other kinds. It's also strong, and it can be trained to be stronger, But it tires easily. It needs rest. It can't work all the time. That's why it has to take turns, fiber by fiber, unit by unit, even when you're standing still. Smooth muscle is different. It's not striped. It's smooth, as the name says. The proteins inside it are not arranged in those neat repeating units. They're arranged more loosely, like a net, so the whole cell can shorten in any direction. Smooth muscle is slower than skeletal muscle. It contracts and relaxes over seconds or minutes, not in fractions of a second, but it can hold a contraction for a very long time without getting tired. That's because it uses energy very efficiently, and it doesn't need a constant stream of nerve signals to stay contracted. It can hold its pull for a long time, like a hand holding a door shut, not with great force, but with great patience. Smooth muscle is found in the walls of hollow organs, the stomach, the intestines, the bladder, the blood vessels, the airways. It squeezes slowly and rhythmically, moving things along or changing the size of the tube. When the smooth muscle in an artery tightens, the artery gets narrower and less blood flows through. When it relaxes, the artery widens and more blood flows through. That's how the body controls blood pressure, how it decides which parts of the body get more blood at any moment. All of it happening without you having to think about it. Smooth muscle is the quiet worker, the one who never asks for recognition, just keeps doing the slow, essential tasks that keep the whole system running. And then there's cardiac muscle. It's found only in the heart. It's striated, like skeletal muscle, so it has the same kind of orderly internal structure. But it's also branched, with cells connecting to each other in a network, so the whole heart can squeeze as one unit. Cardiac muscle has its own rhythm. It doesn't need the nervous system to tell it to beat. It has a little cluster of special cells that generate their own electrical signal, the heart's own pacemaker. That signal spreads through the heart muscle from cell to cell, through tiny connections that let the electrical impulse flow from one cell to the next. So the heart is a muscle that conducts its own music. The nervous system can speed it up or slow it down, but it doesn't start the beat. The beat comes from within. That's why the heart keeps beating even when you're unconscious, even when the brain is deeply asleep, even in the quietest, darkest part of the night. It's the first muscle to work and the last one to stop, and it never gets a full rest, not really. It gets tiny rests between beats, long enough to refill with blood, but it never lies down and stops. It's the most patient, the most constant, the most faithful of all the muscles. It will beat billions of times in a life, and every single beat is a pull and a release, a squeeze and a soft letting go. Squeeze, release, squeeze, release. The oldest rhythm in the world, older than speech, older than walking, older than thought. The first thing you ever heard, in the warm dark before you were born, was the sound of that muscle working, your mother's heart beating close and steady, and behind it, your own. The very first muscle you ever used was the one in your own chest, before you even knew what a chest was. So the three kinds of muscle, working together in their different ways, cover the whole range of what the body needs. Fast and strong, for movement. Slow and patient, for the organs. Constant and rhythmic, for the heart. All of them sharing the same basic idea. Shorten, pull, release. Shorten, pull, release. It's the simplest trick in the living world, and it's enough to build a body from, the way a single kind of brick is enough to build a house if you know how to arrange it. Now, because muscles are alive and working, they produce heat. That's a small thing, but it's important. The chemical reactions that let myosin pull on actin are not perfectly efficient. They lose some energy as heat. It's the same with any engine. A car engine gets warm when it runs. A light bulb gets warm when it glows. A muscle gets warm when it pulls. And that warmth is not waste. The body uses it. The body needs to stay at a very specific temperature, around 37 degrees, and muscle heat is one of the main ways it maintains that. When you're cold, the body makes the muscles shiver. Shivering is just many small, rapid muscle contractions happening all over the body at once. They're not doing any useful movement. They're just pulling and releasing, as fast as they can, and the heat from all that pulling warms you up. That's why you shake when you're cold. It's the body's furnace turning on. The muscles are burning fuel and making heat, and that heat spreads through the blood and warms the core. Even when you're not shivering, the muscles are producing a low, steady amount of heat just by being alive. The heart, the gut, the muscles of the back and legs, all of them are quietly generating warmth. When you lie in bed under a blanket, that warmth builds up around you, trapped by the fabric, until the space under the covers is warmer than the room. That's you. That's your muscles. That's the body keeping itself at the right temperature, even in sleep. It's one of the reasons the bed feels so good when you first get in, and so hard to leave when the morning comes. The muscles have been working all night, not to move you, but to keep you warm. And as the night goes on, the body's temperature changes. It drops a little, just a fraction of a degree, as part of the sleep rhythm. The muscles relax, the blood vessels in the skin open up a little, and heat leaves the body more easily. That's why people often feel a little cooler in the middle of the night. The body is lowering its thermostat, just slightly, to help the deep rest come. Then, near morning, the temperature begins to rise again, the muscles slowly increase their tone, and the body prepares to wake. It's all part of the same slow cycle. The muscles are not separate from sleep, they're woven into it. They help to make it possible. The lowering of muscle tone, the drop in temperature, the slowing of the breath, the steady beat of the heart, all of it is the body's way of saying, yes, now is the time for rest. Yes, it's safe to let go. And the more you can let go, the more the body can do its quiet work. There's something else about muscles that often goes unnoticed until it's pointed out, and that's the way they protect the body from injury, not just by moving it out of danger, though they do that too, but by their very presence. The muscles are a layer of soft armor. They cover the bones and the organs. The muscles of the back cover the spine. The abdominal muscles cover the belly. The gluteal muscles cover the pelvis. The muscles of the thigh cover the femur. They're not hard like bone, but they're thick and yielding, and they absorb impact. When you bump into something, it's usually the muscle that takes the hit. It deforms a little, then springs back. It spreads the force out. It protects the deeper structures. That's one reason why people with stronger muscles often have fewer injuries. Not because they're invincible, but because the muscles act as a cushion. They brace the joints, they steady the bones, they keep the body from folding in ways it shouldn't fold. Even at rest, the muscles are providing this protection, just by being there, just by holding their shape. The body is never completely unguarded. It's always wrapped in itself, soft and strong at the same time. And that wrapping is not just physical. There's a deep, felt sense of being held that comes from the muscles when they relax. You might notice it now, if you turn your attention inward for just a moment. The weight of the blanket on your legs, the pressure of the mattress against your back, the way the muscles around your eyes have gone soft, the way the jaw is no longer clenched, the way the shoulders have settled down away from the ears. All of that is the muscular system letting go. And when the muscles let go, the mind often follows. It's hard to feel anxious when the body is heavy and warm. It's hard to hold on to the day when the body has already put it down. The muscles know how to rest, and they can teach the rest of you, if you let them, not by doing anything, just by being still, just by softening, just by letting the weight of you sink into the bed, and letting the bed hold you up in return. So we've come a long way from the first moments of this, when we were just settling in and making sure the light was low. We've gone down into the cell and up to the whole body. We've looked at the 3 kinds of muscle, and the way they pull, and the way they rest. We've looked at the brain's map of the body, and the nerves that carry the signals, and the chemical that crosses the gap. We've looked at the heart, and the gut, and the walls of the blood vessels, and through all of it, the same simple truth has been running underneath, like a stream under ice. The body is made of pull and release. It's made of work and rest. It's made of the same rhythm that's in the heart, the breath, the waves, the seasons. And you don't have to understand it to be part of it. You already are part of it. You've been part of it since before you were born, and you'll be part of it all your life. The muscles will keep pulling, the heart will keep beating, the breath will keep rising and falling, and the body will keep holding you, even when you're not awake to notice. The night is long, and there's no need to reach its end. There's no test at the end of this. No one is checking to see what you remember. The only thing that matters is that you're lying there, warm and still, letting the body do what it does. If you fall asleep in the middle of this, that's not a failure. That's the whole point. That's the body saying, yes, I've heard enough, I'm ready. And when that happens, the voice can keep going, soft and steady, like rain on the roof, and you don't have to follow it. You can just drift, the way a boat drifts when the ropes are untied and the current is slow and the shore is already far behind. The muscles know the way. The breath knows the way. The night knows the way. You don't have to steer. You only have to let go, and let the pull and release, the old rhythm, carry you the rest of the way home. There's a particular kind of quiet that settles over a room when the night has fully arrived. Not the early quiet when you first turn out the light and the day is still echoing, but the deep quiet, the one that comes later, when the house has stopped creaking, when the street outside has gone still, when even the refrigerator seems to be holding its breath. That's the quiet you're in now, or near enough. And the body knows this quiet. It's been waiting for it all day, underneath the noise and the movement. It's the quiet the muscles remember, from long ago, from all the nights before this one, from all the hours of sleep that have kept you alive without you ever having to ask. Let's go back to something simple, because simple things are the ones that settle the mind. A muscle is a living cord. It's attached at one end to something still and at the other end to something that moves. When it shortens, the moving part moves. When it lengthens, the moving part returns. That's it. That's the whole engine. Everything else, all the names and all the chemistry, all the fibers and all the signals, is just the body's way of making that simple thing work in 1,000 different ways. The bicep is a living cord. The heart is a living cord, wrapped into a hollow ball. The intestine is a living cord, coiled and layered. The walls of the arteries are living cords, woven into tubes. The tongue is a living cord, anchored at the back and free at the front, pulling itself into the shapes of words. The diaphragm is a living cord, spread into a dome beneath the lungs, pulling down and relaxing up, pulling down and relaxing up. All night, all day, all your life. Everywhere you look in the body, there's a version of the same thing, something that can shorten and pull and let go. The body is a conversation of chords, all speaking the same old language of tension and ease. And here's a thought that might sit well with you, if you're still awake enough to have thoughts. The act of falling asleep is itself a kind of muscular event. It's not just the brain changing state. It's the body changing shape. The muscles of the face go slack. The forehead smooths. The jaw unclenches. The tongue relaxes and falls back a little. The neck lets the head grow heavy. The shoulders drop. The arms go limp. The hands open, if they were closed. The belly softens. The back settles into the mattress. The legs turn out. The feet point slightly. All of these are changes in muscle tone. They're the voluntary muscles handing the body over to the automatic muscles. The voluntary muscles say, we're done for the day, we're letting go. And the automatic muscles say, all right, we have it from here. The heart keeps beating. The diaphragm keeps breathing. The gut keeps moving. The vessels keep their slow, steady hold. And you, the part of you that thinks and plans and remembers, you can finally step away. The body doesn't need you right now. It has everything under control. That's the bargain of sleep. You let go of the body, and the body keeps you alive. And if you've ever had the strange sensation of falling just as you were about to sleep, that's the muscles in the middle of the handover. Sometimes, as the body shifts from waking tone to sleeping tone, there's a little hiccup, a sudden brief contraction, usually in the legs, a jerk, a twitch, a feeling of stepping off a curb that isn't there. It's called a hypnic jerk, and it's completely normal. It's just the motor system making the change from one mode to another, and for a split second, the signal gets crossed. The body isn't startled, it's just adjusting. It happens to nearly everyone now and then. It's not a sign that anything is wrong. It's a sign that the body is doing exactly what it should be doing, which is letting go. The jerk is the last little wave before the water goes still. Now, because we're here in the deep quiet, and because the body is soft and heavy, let's think about what the muscles do during the night. Not the heart and the breath, which never stop, but the skeletal muscles, the ones that can rest. During the day, they've been working in all sorts of small ways, holding you upright, moving you from place to place, carrying things, reaching, sitting, standing. Even just standing still requires a constant, subtle negotiation of muscle tone. The body is never a statue. It's always making tiny adjustments, swaying slightly, shifting weight from one leg to the other, turning the head, blinking, swallowing. The muscles are never completely still during the day, not even when you think you're being still. There's always a little work being done. But at night, when you lie down and close your eyes, all that stops. The big muscles of the back and legs and shoulders finally get their rest. The blood flow to them slows a little because they don't need as much fuel. The nerves that serve them quiet down. The tiny adjustments stop. The body becomes genuinely still, not the enforced stillness of a person trying to hold a pose, but the natural stillness of a body that has nothing it needs to do. That's the stillness of sleep. It's not tense, it's not held, it's just allowed. And in that stillness, the muscles are not idle, they're recovering. The small amounts of wear and tear from the day are being repaired. The proteins are being resynthesized, the energy stores are being refilled. The little reserves of sugar in the muscle, called glycogen, are replenished while you sleep, so that when you wake, the muscles are ready for a new day. The body is very practical about this. It uses the night shift to do the maintenance work that would be inconvenient to do while you're awake and moving. It's like road crews repaving a street at night, when the traffic is gone. The body waits until you're asleep, and then it sets about fixing things. Tiny tears in the muscle fibers are patched. The immune system moves through the tissues, looking for anything that needs attention. The nervous system rehearses the movements you learned during the day, strengthening the pathways. All of this happens while you lie there, warm and still, unaware. The body is never more busy with upkeep than when you're asleep. And that's worth remembering, because it means that sleep is not wasted time. It's not a pause in living. It's the part of living that makes the rest possible. The muscles know this. They've been through this cycle every night of your life. They don't resist it. They don't try to stay awake. They simply let go and let the body do its work. You can do the same. You can trust the process. You can let the body take over. It's been doing this for a long time, and it's very, very good at it. Now, there's one more thing about muscle that we haven't spent much time on, and it's a thing that might help you sink even deeper, because it's about the relationship between muscle and mind. You see, the muscles are not just machines that carry out orders. They also speak back. The state of the muscles tells the brain how the body is doing. When the muscles are tense, the brain reads that as a signal that something needs attention. When the muscles are soft and warm, the brain reads that as a signal that all is well. This is why a warm bath or a massage makes you feel sleepy. It's not just the warmth. It's the message the muscles send up to the brain. Soft muscles say, it's safe to rest. Heavy limbs say, there's nothing to run from. Slow breath says, the danger is gone. The brain listens to these messages. It doesn't argue with them. It just responds. When the body is calm, the mind calms down too. When the body is still, the thoughts slow down. The muscles are the first line of the mind's peace. They can lead the mind into rest, if you let them. And right now, as you lie there, the muscles are sending those messages. The weight of your arms on the bed, the softness of your belly, the looseness of your jaw, the heavy, warm feeling in your legs. Each of these is a message to the brain. It's safe, it's quiet, there's nothing to do. The brain hears these messages and responds by turning down the volume on the day. The thoughts get farther apart, the worries lose their edge, the future and the past both fade back, like figures in a fog. What remains is the body, and the bed, and the dark, and the slow, steady rhythm of the breath. That's the doorway. That's how sleep comes. Not by force, not by will, but by the quiet agreement of the muscles and the mind. The muscles let go, and the mind lets go, and the body follows them both down into the soft, dark water. Now let's return, very gently, to the structure of a muscle, because there's a beauty in it that's worth resting on. A whole muscle, like the one in your upper arm, is wrapped in a thin layer of connective tissue. That layer bundles the muscle fibers together into fascicles, little groups of fibers that all run the same direction. Each fascicle is wrapped in its own thin layer, and each individual muscle fiber, each single cell, has its own delicate wrapping too. So the muscle is a thing of layers, like the body itself, layer within layer, from the whole muscle down to the single cell, each one wrapped and supported by the connective tissue around it. And at the ends of the muscle, all these layers come together and fuse into the tendon, which anchors to the bone. So the connective tissue of the muscle is not separate from the tendon, it's continuous with it. The muscle and the tendon are one piece of fabric, just different in texture. The muscle part is soft and contractile. The tendon part is dense and strong, but they're woven together, so when the muscle pulls, the pull travels through the connective tissue into the tendon, and from the tendon into the bone. It's all one long, continuous sheet of tension. The body is not made of separate parts bolted together. It's made of continuous layers that flow into one another. Skin into tissue, tissue into muscle, muscle into tendon, tendon into bone. Nothing is separate. Everything is connected. That's the deeper structure, the one you can only feel when you're very still and very quiet. The body as one single, unbroken fabric, holding itself together, moving with the breath, resting in the dark. And when you think of it that way, the idea of letting go becomes even sweeter, because you're not just relaxing a list of muscles, you're allowing the whole fabric to soften. The tension that runs through the body, from the scalp to the soles of the feet, is not many separate tensions. It's one tension, with many places where it gathers: the jaw, the shoulders, the lower back, the belly, the hands. When one part softens, the rest can follow. When the shoulders drop, the neck eases. When the neck eases, the head grows heavy. When the head grows heavy, the thoughts slow. It's a chain, a cascade, a slow, gentle unraveling of the day's tension, one part at a time, until the whole body is lying there like a cloth, laid out on a warm stone, with no folds, no creases, no effort. That's what sleep is, at the level of the muscle. A full, soft unfolding, a giving over of the whole fabric to gravity, to the bed, to the night. And here you are, still listening, or not listening, or somewhere in between. The words have become like the sound of your own breathing, regular and soft, not something you need to follow. If you're still awake, let this be enough. Let the sound of these words be the last thing your conscious mind hears before it lets go. There's nothing more to take in tonight. You've already done more than enough. The body is warm, the bed is soft, the muscles are heavy, the breath is slow, the heart is steady, and the night goes on, patient and endless, holding you in its dark, quiet hands. You don't have to do anything else now. You can just be here, in the deep quiet, in the soft, continuous fabric of your body, and let the rhythm of pull and release, tension and ease, carry you all the way down. The last thing to let go is the listening itself, and when that goes, there's just the dark, and the breath, and the heart, beating its old, slow beat, like a clock in a room where no one is counting the hours. The body has a way of knowing things that the mind has forgotten. It knows how to rest. It knows how to heal. It knows how to keep the heart beating and the lungs filling and the blood moving, all without a single instruction from you. And it knows how to be still. Not the stillness of a held breath, not the stillness of a person waiting for something, but the deep, settled stillness of a body that has finally been allowed to put everything down. That's the stillness we're in now, or near enough. The kind that comes when the room is dark and the blankets are warm, and the day has already drifted far away. You don't have to do anything to get there. You're already there. The body has been carrying you toward it all along, one soft muscle at a time. Let's think for a while about what a muscle feels like, not from the inside of a textbook, but from the inside of you. A relaxed muscle is soft. It yields. If you press on it, it gives a little, like a cushion. A contracted muscle is firm. It resists. It bunches up under the skin, hard and round. That difference between soft and firm is the difference between rest and work. And the body is always moving between those two states, soft, firm, 100 times a minute, in places too small to notice. The heart does it, the lungs do it, the muscles of the face do it, when you smile and then let the smile go. The muscles of the hand do it when you hold a cup and then set it down. The whole body is a landscape of softness and firmness, changing from moment to moment, like weather moving across a field. And right now, in the dark, the softness is winning. The muscles have been given permission to let go, and they've taken it. The firmness of the day has drained out of them, and what's left is warmth and weight and a kind of liquid stillness that spreads from the center of the body out to the fingers and toes. And the strange thing is, the more you notice this softness, the deeper it goes. It's as if the muscles have been waiting for you to pay attention, not with worry, but with a gentle, curious awareness. The jaw, if you think about it, is probably slightly open. The tongue is resting on the floor of the mouth. The space between the eyebrows is smooth. The shoulders are no longer up around the ears. The hands are open, maybe, or loosely curled, whichever they chose on their own. The belly is rising and falling, not because you're making it, but because the diaphragm is doing its slow, patient work. The legs are heavy, so heavy, like bags of warm sand. The feet are turned out or turned in, but either way they're still. The whole body is settled, and the more you notice that, the more settled it becomes. It's a kind of feedback loop. The brain notices the softness, and the brain says, "Oh, we're resting now," and the muscles soften even more. And the brain notices the new softness, and it lets go a little more, and the whole cycle repeats, slowly, gently, until the body is so soft that it feels like it's melting into the bed. That's the doorway to sleep. Not a single event, but a gradual softening, a slow sinking, a letting go that happens in layers. The outermost layer is the voluntary muscles, the ones you can move on purpose. They're the first to go. Then the deeper layer, the muscles of the trunk and the spine, the ones that hold the posture, they let go next. Then the small muscles of the face and the throat, the ones that hold the expressions and the voice. They soften too, and finally even the muscles of the breath begin to slow, and the breath becomes shallow and regular, and the body is no longer something you're holding up, but something you're resting inside. That's what it means to fall asleep. The body doesn't turn off, it turns down, it lowers the lights. It pulls the blanket up, it lets the fire go to embers, and the mind, which has been watching all this from somewhere inside, finally closes its eyes and lets go of the last little thread of the day. Now, let's walk through the body once, from head to toe, and notice the muscles as they rest. Not to do anything, not to change anything, just to be with them for a moment. The muscles of the scalp are very thin and very quiet. They can't do much. They just lie over the skull like a soft cap. The forehead is smooth. The muscles around the eyes are soft. The eyelids are closed, and the tiny muscles that close them are barely working at all. The muscles around the mouth are loose. The lips are slightly parted maybe, or just touching. The jaw is relaxed, and the big muscles that close the jaw, the ones that work so hard during the day when you chew and talk and swallow, are finally at rest. The neck is soft. The head is heavy against the pillow. The muscles of the neck are no longer holding the head up. They're just letting it be, letting the pillow take the weight. The shoulders are wide and soft, spreading into the bed. The muscles of the upper back, which spend so much time holding the shoulders in place, have let go. The chest is moving gently, and the muscles between the ribs are doing their slow, easy work. The belly is soft and still, except for the gentle movement of the breath. The muscles of the lower back have settled into the mattress, and there's no strain in them at all. The hips are heavy. The gluteal muscles, the biggest muscles in the body, are completely at ease. The thighs are warm and still. The knees are slightly bent or straight or whatever they chose. The calves are soft. The feet are still, and even the tiny muscles in the feet, the ones that work all day to keep you balanced, are resting. From the top of the head to the soles of the feet, there is no part of the body that needs to work right now. The whole muscular system is at peace. And here's something worth knowing. The body likes this. It's not just tolerating the rest, it's grateful for it. The muscles have been working all day, even if you didn't notice. They carried you, they held you, they adjusted and balanced and lifted and reached. And now they get to recover. The blood flows through them slowly, bringing fresh oxygen and carrying away the waste products of the day. The small tears in the fibers are being repaired. The energy stores are being refilled. The muscle cells are making new proteins, new enzymes, new mitochondria. They're rebuilding themselves, cell by cell, for whatever tomorrow will bring. This is not a passive process. It's an active one. The body is busy, even in stillness. It's repairing and renewing and restoring. And the best part is, none of it requires your attention. You don't have to supervise. You don't have to remember. You can just lie there, warm and heavy, and let the body do what it does best. And while the muscles are recovering, they're also learning. Every movement you made today left a trace in the nervous system. The pathways between the brain and the muscles were used, and using them made them a little bit stronger. During sleep, the brain replays these patterns. Not in real time, but in fast, quiet bursts. It's like a librarian going through the day's records and filing them away. The movements you practiced, the new skills you tried, the old habits you repeated, all of them are being woven more tightly into the fabric of the nervous system. So when you wake up, you'll be a little bit better at them than you were when you fell asleep. That's one of the hidden gifts of sleep. It's not just rest, it's consolidation. It's the body and the brain working together to make sure that what you learned today stays with you, and you don't have to do anything to make it happen. It happens on its own, in the dark, while you drift. Now, let's think about the tendons for a moment, because they're the quiet partners of the muscles, and they deserve some attention. A tendon is a cord of connective tissue that attaches a muscle to a bone. It's very strong, stronger than the muscle itself in some ways. It has to be, because it takes the full force of the muscle's pull and transfers it to the bone. If the tendon were weak, it would snap under the load. So the body makes tendons out of dense, tough collagen fibers, arranged in parallel lines, like the cables on a suspension bridge. And these tendons are not just passive ropes. They're alive. They have a blood supply, though not as rich as the muscles. They have nerves, though not as many. They respond to use. When a tendon is loaded regularly, it gets stronger. When it's rested, it stays healthy. But when it's overused, it can become inflamed or sore. That's what people mean when they talk about tendinitis. It's the tendon saying, "I've had too much, I need a break." And the fix is usually rest, just rest, and maybe some gentle movement. The body knows how to heal if you give it time. And here's a lovely thing about the tendon and the muscle working together. When a muscle is stretched, it stores a little bit of elastic energy in the tendon. You can feel this if you think about a rubber band. When you stretch a rubber band, it stores energy. When you let it go, that energy is released. The same thing happens in the body. When you walk, The Achilles tendon at the back of the ankle stretches and recoils with every step, storing and releasing energy like a spring. That's part of why walking is so efficient. The body doesn't have to work as hard, because some of the energy is given back by the tendons. The muscles and the tendons together form a kind of spring system, catching and returning energy, making movement smooth and easy. Even the simple act of breathing uses this elasticity. The tissues stretch and recoil, and the breath flows in and out with very little effort. The body is not a machine of rigid levers and stiff cables. It's a machine of springs and soft tissues, tuned to work with the minimum of effort. And when you lie down to sleep, the tendons and the muscles both relax. The springs are unloaded. The elastic energy drains away. The body doesn't need to store any energy for the next step because there is no next step. It can simply rest. The tendons settle into their natural length. The muscles soften around them. The joints open up a little. The whole system goes slack in the best possible way. That's part of why sleep is so good for the body. It's the only time when the springs are completely unloaded, when the tendons and muscles and bones are all in their neutral positions, with no force running through them. For 8 hours or so, the body gets to be completely unloaded, completely free of the forces that shape it during the day. And in that freedom, it heals. Now, let's come back to the breath, because the breath is the thread that runs through all of this. The diaphragm is a muscle, a big dome-shaped muscle that separates the chest from the belly. When you breathe in, the diaphragm contracts and flattens, pulling down and making space for the lungs to fill. When you breathe out, the diaphragm relaxes and rises, and the air leaves. It's that simple. But the breath is not just the diaphragm. The muscles between the ribs help too, lifting and lowering the rib cage. And the muscles of the throat and the nose and the mouth all play their parts, shaping the flow of air. Even the abdominal muscles get involved, especially when you breathe out deeply. So breathing is a muscular act, a coordinated dance of many muscles, happening over and over, all day and all night. And the beauty of it is that it happens without you. You don't have to think, now breathe in, now breathe out. The brainstem does that for you. It sends the signals to the diaphragm and the ribs, over and over, in a rhythm that changes with your needs. When you're resting, the rhythm is slow and shallow. When you're walking, it's a little faster. When you're asleep, it's at its slowest, just enough to keep the body oxygenated, no more. The breath is the most faithful of the body's rhythms. It's been with you since your first moment, and it will be with you until the last. And it never asks for your help. It just keeps going, in and out, a soft tide that moves the whole body. And the breath is connected to the muscles in another way too. When you're stressed, the breath gets shallow and quick, and the muscles tighten. When you're relaxed, the breath gets slow and deep, and the muscles loosen. It works both ways. The muscles and the breath are in a constant conversation. Right now, as you lie there, the breath is probably very slow and very soft. You might not even notice it, but if you do notice it, just for a moment, you might find that the noticing makes it even slower. And as the breath slows, the muscles soften a little more, and as the muscles soften, the mind lets go a little more. It's a cycle, a spiral, a gentle descent into rest, and you don't have to do anything to make it happen. Just lie there, and let the breath breathe, and let the muscles soften, and let the night do its work. The hours are passing now, though you might not feel them. The body doesn't keep time the way the clock does. It keeps its own time, the time of the heart and the breath, and the slow turning of the blood. And in the body's time, there is no hurry. There is no late and no early. There is only the present moment, unfolding at its own pace. The muscles know this. They live in the body's time. They don't rush. They don't worry about the morning. They just rest and recover and prepare in their own quiet way. You can trust them. You can trust the body. You can let go of the clock and fall into the body's time, where the nights are long and soft and full of healing. And when the body is ready, It will wake you, not with a jolt, but with a slow rise, a gradual return of tone and warmth and alertness. The muscles will remember their work. The brain will remember the day. But for now, none of that matters. For now, there is only the dark, and the breath, and the heavy, warm weight of a body at rest. And that is enough. That has always been enough. The night has a way of making everything feel farther away. The sounds, the thoughts, the small worries of the day. They all recede like lights on a distant shore, until all that's left is the near and the warm and the quiet. The body knows this place. It's been coming here every night since the beginning, and it never gets lost. Even when the mind is restless, the body is patient, it waits, it softens. It keeps breathing, and eventually, the mind gives up its holding and follows the body down into the dark. Let's talk now about the muscles of the face, because they are the most social muscles in the body, and they carry a great deal of the day's tension without us ever noticing. There are dozens of them, small and fine, woven into the skin of the forehead, the cheeks, the lips, the chin. They don't attach to bones the way the big muscles do, not all of them. Some attach to the skin itself, or to other muscles, or to the soft tissues around the eyes and mouth. That's what lets them make such a wide range of expressions. The lift of an eyebrow, the crinkle of a smile, the tightening of the jaw, the furrow of concentration. All of these are the work of the facial muscles, pulling on the skin in different directions, creating the living map of the face. And because the face is so involved in social life, it's often the last place to let go at night. The jaw, especially. Many people carry the day's tension in the jaw without knowing it. The masseter, the big muscle at the angle of the jaw, is one of the strongest muscles in the body for its size. It can clamp the teeth together with surprising force. And it does, all day, whenever you're concentrating, or worrying, or holding back something you want to say. By the time night comes, the jaw has been working for hours, and it doesn't know how to stop. But it can learn. It can be reminded. If you notice it now, just notice, not judge. You might find that the teeth are slightly apart, or that the tongue is pressing gently against the roof of the mouth, or that the lips are just barely touching. That's the beginning of release. The masseter softening, the temporalis, the fan-shaped muscle on the side of the head, letting go. The small muscles around the mouth going slack. The whole face smoothing out, like a sheet of water becoming still. That's what sleep looks like on the face. Not a mask, not an expression, but an absence of expression. A return to the resting state, the neutral state, the state the face was in before the world asked anything of it. And below the face, the muscles of the throat are also letting go. The muscles of swallowing, the muscles of speech, the muscles that hold the airway open, all of them softening as the night goes on. The larynx, the voice box, sinks a little lower. The vocal cords relax. The airway becomes a quiet, open passage, and the breath moves through it without a sound. If you've ever heard someone breathe softly in their sleep, that's what it is. The muscles of the throat at rest, letting the air pass in and out like a slow tide through a still channel. It's one of the gentlest sounds in the world, and it means the body is safe, the airway is open, the breath is doing its work. The muscles don't need to try, they just need to be. Now, let's think about the muscles of the hand, because they are another place where the day leaves its mark. The hands are capable of astonishing precision. They can thread a needle, tie a knot, write a letter, hold a spoon, feel the temperature of a cup. All of that precision is the work of muscles, not just in the hand itself, but in the forearm, connected by long tendons that run through the wrist. The fingers don't have muscles of their own, not really. The muscles that move the fingers are mostly in the forearm, and they pull on the fingers through those long tendons, like a puppeteer pulling strings. That's why the forearm gets tired when you write for a long time. The muscles are up there, working, even though it's the fingers that move. And in the hand itself, there are small muscles, the intrinsic muscles, that fine-tune the movements, spreading the fingers, bringing them together, cupping the palm. All of these muscles, in the hand and the forearm, are busy all day, and now, at night, they can rest. The hands lie open or loosely curled on the blanket. The fingers are still, the tendons are slack, the small muscles of the palm are soft. If you've ever woken up with stiff hands, that's just the muscles and joints settling after a night of stillness. It passes. The body warms up, the blood moves, and the hands remember how to move again. And then there are the feet. The feet are the foundation of the body. They carry the whole weight of you, step after step, day after day. The muscles of the feet are small but strong, and they work in a constant conversation with the muscles of the lower legs. The arches of the feet are held up by muscles and tendons, like the cables of a suspension bridge. When you stand, those cables are under tension. When you walk, they stretch and recoil with every step. When you lie down, the cables go slack, the arches relax, the toes spread a little. The feet turn outward, and the whole structure of the foot settles into the soft, warm dark of the bed. It's one of the great pleasures of the body, the moment when the feet are finally unloaded. The weight of the world, quite literally, lifts off them. The muscles that have been holding you up all day get to stop. The bones spread out. The joints open. The soles of the feet, which have been pressed against the ground for hours, feel the softness of the sheet and the warmth of the blanket. And the feet rest, truly rest, for the first time since the morning. All of this resting, all of this softening, is not just a local event, it's a whole body event. The nervous system is deeply involved. When the muscles let go, they send signals to the brain that the body is safe. The brain responds by lowering the levels of stress hormones in the blood. The heart slows, the blood pressure drops, the digestion, which is partly controlled by smooth muscle, becomes more active. The immune system shifts into its nighttime mode, repairing and patrolling. The whole body changes state. It moves from the active, alert mode of the day into the restful, restorative mode of the night. And all of that is triggered, in part, by the simple act of the muscles letting go. It's as if the body has a switch, and the switch is made of muscle tone. When the tone is high, the body is ready for action. When the tone is low, the body is ready for rest. And the switch is not flipped by willpower. It's flipped by lying down, by closing the eyes, by letting the room go dark, by trusting that the work is done. The muscles do the rest. They always have, they always will. And here's a gentle thought. The body doesn't know the difference between a good day and a bad day. It only knows the state of the tissues. A muscle that is tight is a muscle that is ready for something. A muscle that is soft is a muscle that is resting. The body doesn't judge the day, it just responds to the signals. So when you lie down at night and the muscles begin to soften, the body takes that as a sign that the day is over, regardless of how it went. The worries might still be there, but the body has already moved on. It's already in the rest state. The brain might lag behind, still chewing on the day, but the body is patient. It stays soft. It keeps breathing. It keeps sending the quiet signals. And eventually, the brain catches up. It follows the body into the dark. That's the gift of the muscles. They go first. They lead the way. And all you have to do is let them. Now, let's think about the smooth muscle of the gut, because it too is resting, but not in the same way. The smooth muscle of the intestines never stops completely. It moves in slow waves, squeezing and relaxing, pushing the contents of the gut along. This is called peristalsis. It's the same kind of movement that pushes food down the esophagus when you swallow, and it continues all night, slower when you're asleep, but never fully stopping. The body uses the night to digest and absorb, to process what was eaten during the day, to move the waste along the long, coiled path of the intestines. And all of this happens with smooth muscle, the patient, tireless kind. You don't feel it most of the time. It's too gentle. But it's there, a slow wave moving through the dark, working its way from one end of the gut to the other. It's one of the oldest rhythms in the body, as old as the heart, as old as the breath. And it doesn't need your help, it doesn't need your attention, it just keeps moving, all night, all day, all your life. And the bladder, too, is a smooth muscle organ. It's a hollow bag, and its wall is made of smooth muscle that can stretch and hold. All day, it slowly fills. All night, it continues to fill, though more slowly, because the body produces less urine when you sleep. The smooth muscle of the bladder stays relaxed as it fills, letting the bag expand. Then, when the time comes, it contracts, and the urine is released. It's a simple mechanism, but it's a good example of how smooth muscle works. It can hold a stretch for a long time without tiring, and then it can contract, slowly and completely, when the signal comes. And the signal doesn't come from your conscious mind, not always. The bladder has its own reflex, controlled by the lower parts of the nervous system. That's why you can sleep through the night without needing to wake up. The bladder does its work quietly, and the brain, in its deep rest, doesn't interrupt unless it has to. The whole system is designed to let you sleep. The smooth muscle holds, the body waits, and the night passes undisturbed. There's a kind of mercy in that, in the way the body arranges things so that sleep can happen. The heart slows, but not too much. The breath slows, but not too much. The bladder fills, but not too fast. The gut moves, but not enough to wake you. The muscles of the throat keep the airway open. The muscles of the jaw keep the mouth from falling too far open. The muscles of the back keep the spine in a safe position. Every system is tuned for sleep, not perfectly, but well enough, night after night. The body wants to sleep, it's built to sleep, and when you lie down and let it, it does the rest. Now, let's return, for a moment, to the idea of tension and release, because it's the deepest pattern in the whole muscular system, and it's a pattern that shows up everywhere in the living world. The heart squeezes and releases. The lungs fill and empty. The gut contracts and relaxes. The seasons turn from growth to rest. The tide comes in and goes out. The day brightens and darkens. Everything alive is built on this rhythm, the rhythm of effort and ease, of work and rest, of holding on and letting go. And the body is not separate from that rhythm. It is that rhythm. Every muscle, every cell, is a small expression of it. And sleep is the great letting go, the long release, the part of the cycle that makes the next part possible. Without the release, the pull would be meaningless. Without the rest, the work would break the body. So the night is not a pause in life. It's the other half of life, the counterpoint, the silence between the notes. And the muscles know this. They've been living it since before there were words. They don't resist the night. They welcome it. They soften into it, the way water softens into sand. And you can too. You can let the rhythm carry you. You can be the release. You can let go all the way into the dark, warm, waiting quiet, where the body does its silent work and the mind finally rests. The small hours of the night have their own texture. The air feels different, the room seems larger, and the body is so deeply settled that it barely feels like a body at all. It feels more like a warmth, a weight, a slow tide of breath moving in and out. The muscles have done their work, they've softened and let go, and now they're just waiting, not in the way a person waits for a bus, but in the way a field waits under snow, quietly, patiently, without needing to know the time. Let's talk now about what happens to the muscles during the deepest stages of sleep, because it's a different kind of rest than the one at the beginning of the night. When you first fall asleep, the body is still shaking off the day. The muscles are relaxing, but the nervous system is still a little alert. The brain is still flickering between waking and sleeping. Then, as the night goes on, you sink into deeper stages. The brain waves slow down. The body temperature drops a little more. The heart rate falls. The breath becomes very regular and very soft, and the muscles reach their lowest level of activity. This is the stage of sleep that feels the most like being unplugged from the world. The voluntary muscles are almost completely still. The muscle tone is at its lowest point. The body is not moving, not twitching, not adjusting. It's just there, a warm, heavy presence under the blankets, breathing in and out like a slow machine. This deep sleep is called slow-wave sleep, and it's the most restorative part of the night. It's when the body does most of its repair work. The muscles release small amounts of growth hormone, which helps rebuild tissue. The cells make new proteins. The energy stores are replenished. The immune system is at its most active. All of this happens while the muscles are at their most still. It's as if the body says, "Now that you're not using the machinery, I can take it apart and put it back together." The stillness is the point. The stillness is what makes the repair possible. That's why deep sleep matters so much. It's not just rest, it's maintenance. It's the body's chance to do the work that can't be done while you're awake and moving. And here's a curious thing. Even in the deepest sleep, the muscles are not completely silent. They still receive tiny signals from the nervous system. They still maintain a faint thread of tone. They still respond, just barely, to the breath and the heartbeat. The body is never fully off. It's more like a house at night, with the lights low and the doors locked, but the furnace still running and the clocks still ticking. The muscles are the furnace. They're generating warmth. They're keeping the body at the right temperature. They're holding the joints in safe positions. They're doing all of this without any conscious effort, without any movement, without any sound. It's the quietest kind of work there is. The work of simply being alive. Then, later in the night, something shifts. The brain moves into a different stage, the one called REM sleep, which stands for rapid eye movement. This is the stage where dreams are most vivid, and during REM sleep, the muscles do something strange. They become even more relaxed, so relaxed that the voluntary muscles are essentially paralyzed. This is a safety mechanism. The brain is dreaming, and the dreams can be very active. If the muscles were allowed to act out the dreams, the body would thrash and move and possibly hurt itself. So the brain sends a signal that locks the voluntary muscles down. The muscle tone drops to almost zero. The body lies perfectly still, except for the eyes, which move rapidly behind the closed lids, and the breath, which becomes a little irregular. The heart rate might change too. But the limbs don't move. The hands don't move. The jaw stays slack. The body is completely, deeply still, even while the brain is racing through the landscape of the dream. This is one of the most remarkable things about the muscular system. It can be turned off almost completely and then turned back on again. The same muscles that were paralyzed during the dream will be ready to move the moment you wake. The transition is not instant. When you first wake from deep sleep, there's often a few seconds when the body feels heavy and unresponsive. That's the muscles coming back online, shaking off the sleep paralysis, restoring their tone. It's a very normal thing. The body just needs a moment to remember how to move. Then the signals start flowing again. The muscle tone comes back, and the body is ready. It's a daily miracle, so ordinary that no one thinks about it. The muscles let go of their hold on the body, and then they take it up again, all without asking. Now, let's think about the muscles in the cold. The night is often cooler than the day, and the body responds to that in a very particular way. When the room is cool, the muscles in the walls of the blood vessels near the skin tighten up. That's smooth muscle doing its quiet work. The vessels get narrower, and less blood flows to the skin, which means less heat is lost to the air. The body keeps its warmth deeper inside, around the organs. At the same time, the skeletal muscles might start to shiver, just a little, not enough to wake you, but enough to generate heat. Shivering is a series of small, rapid contractions, and each contraction produces a tiny amount of warmth. It's the body's furnace, the same one we talked about earlier. And all of this happens while you're asleep, without you knowing. The body monitors its temperature, adjusts the blood flow, turns the muscles up or down, and keeps the whole system in balance. It's a beautiful example of the two kinds of muscle working together. The smooth muscle in the vessels, squeezing to keep the heat in. The skeletal muscle in the limbs, twitching to make more heat. All of it automatic, all of it in the dark. And if the room is warm, the opposite happens. The vessels open up, the blood flows to the skin, the muscles stop shivering, the body lets the heat go, so it doesn't overheat. It's the same system working in reverse. The body is always adjusting, always balancing, always trying to keep the temperature just right. And the muscles are at the center of it, because they're the body's main source of heat. Even at rest, they produce warmth. Even in sleep, they respond to the temperature of the room. Even in the deepest quiet, they're doing their part. Let's turn now to something softer. The relationship between the muscles and the breath is one of the most intimate in the body. The diaphragm, the big dome-shaped muscle under the lungs, is the main muscle of breathing. It works all day and all night, but it changes its rhythm depending on what's happening. During the day, when you're active or talking or moving, the breath is faster and shallower. The diaphragm is working in short, quick strokes. At night, when you're lying still and the body is at rest, the breath slows down. The diaphragm moves in long, easy waves, pulling down slowly, rising slowly, pulling down again. It's a rhythm that can almost hypnotize the mind if you pay attention to it. In and out, up and down, pull and release. The diaphragm is the most patient muscle in the body. It never rests, but it never rushes. It just keeps breathing over and over, in the same gentle rhythm, all through the night. And the muscles between the ribs, the intercostals, help the diaphragm. They lift the rib cage slightly with each breath, making more room for the lungs. At rest, they do very little. The breath is mostly the work of the diaphragm, but they're there, ready, if the breath needs to deepen. The abdominal muscles also take part, especially when you breathe out. At rest, the out-breath is mostly passive. The diaphragm relaxes, the lungs empty, and the air leaves on its own. But the abdominal muscles are ready to help if needed, pushing the air out more forcefully. All of these muscles, the diaphragm, the intercostals, the abdominals, are part of the same team, the breathing team, and at night they work together in the gentlest possible way, moving the air in and out with hardly a sound. And the sound of your own breathing, if you can hear it, is one of the most soothing sounds there is. It's a small sound, a soft sound, but it's full of meaning. It means the airway is open, the lungs are working, the diaphragm is doing its slow dance, the body is alive. And because the body is alive, the mind can rest. The breath is like a rope that ties the mind to the body. As long as the breath is there, the mind doesn't have to do anything. It can just follow the rope down into the dark, in and out, soft and slow, until the following stops and the listening stops and there's only the breathing, going on, like a tide that never quite reaches the shore. Now, let's think about the muscles of the neck one more time, because they are so often the place where the day's tension gathers. The neck is a narrow bridge between the head and the body. It has to be strong enough to hold up the head, which is heavy, and flexible enough to let the head turn and tilt and nod. The muscles that do this are many and layered. Some are deep and small, connecting one vertebra to the next. Some are long and thick, running from the base of the skull down to the shoulders. Some are in the front of the neck, some in the back, some on the sides. All of them work together to keep the head balanced. And when you lie down, the neck finally gets a break. The pillow takes the weight of the head. The muscles of the neck don't have to hold it up anymore. They can soften, they can lengthen, they can let the head sink into the pillow like a stone into soft sand. And as they soften, the whole body seems to follow. The neck is a kind of gate. When the neck lets go, the rest of the body lets go too. The shoulders drop, the back eases, the arms go heavy, the legs go still. It all starts in the neck, the narrow bridge, the place where the head meets the body. Let it soften, let it rest. The pillow is holding the head now. The muscles don't have to do a thing, and the shoulders, too, are a place where the day collects. The muscles of the shoulders are broad and strong, built for lifting and carrying and reaching, but they're also built for holding, and sometimes they hold too much. The tension of the day, the small stresses and strains, the hours of sitting and working and carrying things, all of it tends to gather in the shoulders. They creep up toward the ears, they tighten, they ache. And at night, when you finally lie down, the shoulders can be slow to let go. But they can let go. They will let go, if you let them. The bed takes the weight of the arms. The shoulder blades settle into the mattress. The muscles around the shoulder blades, the trapezius and the rhomboids and the rest, begin to soften. The shoulders widen. The upper back flattens. The whole upper body feels like it's spreading out, melting into the bed, becoming part of the warm, dark surface beneath it. That's the gift of the shoulders at rest. They carry so much, and now they can put it down. And the lower back, too, deserves a mention. The lower back is another place where the day's weight settles. The muscles of the lower back work hard all day, holding the spine upright, supporting the trunk, absorbing the shocks of walking and bending and lifting. When you lie down, especially if you lie on your back with your knees slightly bent, the lower back gets to rest. The curve of the spine settles into a natural position. The muscles along the spine, the erector spinae, soften. The small, deep muscles between the vertebrae let go. The whole lower back feels supported, not by muscle, but by the bed. The work of holding is handed over to the mattress. And the muscles, for the first time all day, are free. That's why lying down feels so good when you're tired. It's not just the rest, it's the handing over. The muscles have been holding you up for hours, and now they can stop. The bed takes over. The body lets go. It's a small, quiet miracle, and it happens every night. And as the body lets go, the mind can let go too. The two are not separate. The mind lives in the body, is shaped by the body, listens to the body. When the body is tense, the mind is tense. When the body is soft, the mind is soft. When the body is heavy and warm and still, the mind begins to drift. It stops trying to solve the problems of the day. It stops rehearsing the conversations. It stops making lists. It just follows the body into the dark, the way a child follows an older sibling through a quiet house. The body knows the way. It's been this way 1,000 times. And the mind, tired and willing, finally lets itself be led. That's the last step. The body is soft, the breath is slow, the heart is steady, and the mind, having nothing left to hold, lets go. And sleep comes, not like a hammer, but like a tide, rising slowly, softly, until the shore is covered and the world is gone. The night is half over now, or more than half, or maybe it's just beginning. It doesn't matter. Time doesn't matter in the body's world. The muscles don't know what hour it is. They only know that it's dark and warm and still. They only know that the work is done and the rest is here. And they're resting, truly resting, in the way only living things can rest. The heart is beating, the breath is moving, the blood is flowing, and the muscles, the long cords and soft sheets and patient fibers are at peace. The whole body is at peace. And you, wherever you are in the drifting space between waking and sleeping, are at peace too. You can let go now. You can let the words fade. You can let the night take over. The body will stay. The breath will stay. The muscles will stay, soft and warm and still, holding you together while you sleep. And that's all they've ever wanted. That's all they've ever needed, to rest and be ready and begin again. The last part of the night is the softest. The room has settled into itself. The dark has been there so long it feels like it was never anything else. And the body, lying warm and still under the blankets, has done what it came to do. It has rested. It has repaired. It has kept the heart beating and the breath moving and the blood flowing, all through the long, quiet hours, without once asking for help. Now the night is almost over, and the body knows it, but it doesn't hurry. It never hurries. It just begins, very slowly, to shift from one kind of quiet to another. The muscles are the first to stir, long before the mind does. The tone that was so low during deep sleep begins to rise, just a little. The jaw firms up almost imperceptibly. The hands, which were lying open or loosely curled, might close and then open again. The feet might shift under the blanket. The legs might stretch, not a full stretch, but a small one, the kind the body does on its own, testing the joints, feeling the length of the muscles after hours of stillness. These are not movements of waking, they're more like the movements of a cat before it opens its eyes. The body is running its hands over itself, checking that everything is still there, still warm, still working. It's a very old ritual, older than language, older than thought. The body waking itself up, one muscle at a time. And if you're still awake enough to notice any of this, you might feel the first faint light of morning on the other side of your closed eyelids. You might hear the first bird, or the first car, or the soft click of the heating coming on. The night is thinning, the dark is not as deep as it was. And the body, which has been resting in the dark for hours, begins to remember the day. Not the details, not yet, just the fact of it. The fact that there will be a day. The muscles remember how to hold. The bones remember how to carry. The heart remembers its faster rhythm, the one it uses when the body is up and moving. The breath remembers how to quicken. All of these memories are still far away, but they're coming closer. They're gathering at the edge of sleep, like people gathering on a shore, waiting for the tide to go out. But there's no need to rush toward them. The body knows how to wake slowly. It's done it every morning of your life. There's a rhythm to it, a sequence. The muscles tighten a little, the breath deepens a little, the heart speeds a little, the body temperature rises a little. The brain waves change, from the slow waves of deep sleep to the faster waves of waking. And then, at some point, the eyes open. Or they don't. Maybe the body settles back down and sleep comes again, lighter this time, more like a doze. That's all right too. The body takes what it needs. It always has. It knows how much rest it needs, and it knows how to get it, if you let it. And as the night ends and the morning begins, the muscles are ready. They've been repaired and refueled and rested. The small tears in the fibers have been healed. The energy stores have been topped up. The nerves have rehearsed their pathways. The whole system has been reset, not to zero, but to a kind of quiet readiness. The muscles are not tense, they're not eager, they're just there, warm and able, waiting for the first real movement of the day. It might be a stretch, long and slow, the kind that pulls the whole body from the fingers to the toes. It might be a yawn, with the jaw opening wide and the breath rushing in. It might be the simple act of rolling over, or sitting up, or putting a foot on the floor. Whatever it is, the muscles will do it. They've been doing it every day since the beginning. They know how. And so we come to the end of this long, slow walk through the muscular system. Not an ending with a period, but an ending like the end of a night, which is really just the beginning of a day. The muscles will keep working, the heart will keep beating, the breath will keep moving, the body will keep holding itself together, layer by layer, pull by pull, release by release. And you don't have to remember any of the words that were spoken here. You don't have to remember the myosin or the actin, the sarcomeres or the motor units, the smooth muscle or the cardiac muscle, the tendons or the fascia. The body already knows all of it. It's been knowing it since before you were born. All you have to do is rest and let the body do its quiet work. If you'd like to come back to any of this while you're awake, the No Fluff Anatomy and Physiology Guide is at the link in the description, and it covers the same ground in a form you can actually read. And if you want the same subject taught properly, with energy and clarity and a little more structure, the No Fluff Academy channel is there for you too. But not now. Now there's nothing you need to do, nothing to study, nothing to remember. Just the slow, soft feeling of the night ending, and the body warm under the blankets, and the breath moving in and out like a tide that never quite reaches the shore. The room is probably lighter now. The first grey light of morning is beginning to edge in around the curtains. The body knows it. The muscles are slowly waking. The heart is beating a little faster. The breath is a little deeper. But you don't have to open your eyes. Not yet. You can stay here, in the warm space between sleeping and waking, for as long as you like. There's no rush. The day will still be there when you're ready. The muscles will still be ready. The body will still be strong and rested and full of quiet life. And the heart will keep beating, and the breath will keep moving, and the muscles will keep pulling and releasing, all the way through whatever comes next. Thank you for resting with me. Thank you for letting the words wash over you, even if you didn't follow them all, even if you drifted in and out, even if you fell asleep halfway through. That was the point. That was always the point. The body needed the rest more than the mind needed the words, and the body got what it needed. The muscles are soft, the breath is slow, the heart is steady, and the night, long and dark and patient, is finally at an end. Not with a bang, not with a flourish, but with the slow, gentle return of the light, and the quiet certainty that the body is ready, and the day can begin.